This video will use a website to help us walk through solving a system of equations with inverse matrices. Here's the example. Statistics show that at a university, 90% of the students who live on campus during a given semester will remain on campus the following semester. And 70% of students living off campus during a given semester will remain off campus the following semester. Let X and Y denote the number of students who live on and off campus this semester, and let U and V be the corresponding numbers for the next semester. Okay, so a little bit of information that's helpful here is that 90% of on-campus students stay on campus the next semester. That means 10% of on-campus students right now become off-campus students the next semester. And 30% of off-campus students will become on-campus students the next semester, while 70% of the off-campus students stay off campus. So I needed to figure that out before I could actually write my equations. Now with my equations, I'm going to approach the next semester with on and off-campus students. The first equation says on-campus students. Okay, so we're going to focus on on-campus students next semester. So X was the number of on-campus students in the first semester. 90% of those are going to stay on campus. Now we're going to have a few more on-campus students, and that is the 30% that used to be off campus are now coming on campus. And that will equal the total number of on-campus students, which is U. For off-campus students, 10% that used to be on campus become off campus, and 70% that were off stay off. So the total number of off-campus students is V. Okay, so that helps me write my matrices. Matrix A is going to be the matrix that's a 2 by 2 with the coefficients for X and Y. And then matrix X, which is our variables. And that will equal matrix B, which are the U and the V, since I don't have values for that. Okay, the second part, part B, says solve the resulting matrix for X. It just wants X equals because at this point in time we don't have any values for U and V. So X is the matrix XY. And that is going to equal matrix A, which is, oh, sorry, my apology. It's going to equal the inverse of matrix A. So 0.9, 0.3, 0.1, and 0.7 to the inverse power. And that will be multiplied with matrix B, which is U and V. So that's what matrix X equals. It says, suppose that out of a group of 24,000 students, 15,000 currently live on campus and 9,000 live off campus. How many lived on campus last semester? All right, so now they are giving me the fact that 24,000 is the total number of students, and 15,000 are going to live on campus and 9,000 will live off campus. The question is, how many lived on campus last semester? So last semester was X and Y. That tells me that this 15,000 and 9,000 are the values for U and V. Okay, so over on my website here, I'm going to type in matrix A, which is 0.9, 0.3, 0.1, and 0.7. And I type in matrix B, which is 15,000 and 9,000. I need to calculate A to the inverse, and that is going to be multiplied with B. And to make sure that the website reads this correctly, I want to use some parentheses. All right, so I took the inverse of matrix A, multiplied it with matrix B, and it gave me the answer of 13,000 and 11,000. That means the 13,000 is representing the X value, which was the number of on-campus students, and the 11,000 is representing the number of off-campus students. And that was last semester. Okay, so I had said how many lived on campus last semester, that'd be 13,000. And then it says how many will live off campus, and that should say also last semester, which is 11,000. Let's look at question D. Suppose that out of a group of 24,000 students, 15,000 currently live on campus and 9,000 live off campus. How many will live on campus next semester? How many will live off campus next semester? So this is looking futuristically. And if we look back at our labels for X and Y, U and V, we can see that next semester is for the variables U and V. That means our values that we have of 15,000 and 9,000 are the current semester that we're considering, and those are the X and Y values. So this problem is solved differently than the one before. Instead, we are going to take our matrix A of 0.9, 0.3, 0.1, and 0.7, multiply it with matrix XY, and that will equal our answer of matrix UV. So over on matrix calc, I can multiply matrix A and B and find out that the answer is 16,200 and 7,800. That means next semester on campus will be the 16,200, and off campus next semester will be 7,800. In Math Excel, they can ask a question at the very end that actually blends problem C and problem D that I've presented. So be careful with how they are asking the question and make sure that you're looking at, is it last semester or is it next semester that they're looking for, and also if they are looking for on-campus or off-campus students.